Welcome to the section on Introduction to Identities. We're starting out with a few basic identities, which are so important that you have to memorize them. Those are the basic reciprocal identities, such as the cosecant equals 1 over sine, which you need to know anyway because, as I had mentioned, they're actually not on your graphing calculator. The cosecant and cotangent are not. You need to know the ratio identities, which are, for example, tangent equals sine over cotangent. And you need the Pythagorean identities, such as sine squared plus cosine squared equals 1. You can always look them up, which should be in the front or back of your textbook. But still, we need them all the time, and that's why they need to be memorized. Okay, let's get started. Reciprocals. I had already mentioned these here. The reciprocals are cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, and cotangent theta equals 1 over tangent theta. So memorize these. That actually reminds me that in the last session that I had recorded, I had pointed out where you find cosine and sine between -1 and 1, and cosecant and secant you find either smaller than -1 or larger than +1. And I had mentioned tangent is anywhere in the real numbers. And I'm not sure if I pointed out, maybe I did point out cotangent is also anywhere in the real numbers. So again, memorize the above. Since calculators have only sine, cosine, and tangent, we must use 1 over sine or sine in parentheses and then to -1 in order to compute cosine. We'll come to the cotangent. One little thing to point out, though, is that as we use 1 over sine or parentheses sine to -1, don't try this here. Might not even be possible, because this unfortunately means something else. It means the inverse function or arcsine. It does not mean the inverse. I know it's confusing, but that's just the way it's written in math, that this one here is the inverse function. It is not the reciprocal. Let's calculate a few on a graphing calculator. Let's see that I open that. For example, you may want to calculate cosecant of 40 degrees. So we do 1 divided by sine of 40 degrees. And that will be the cosecant. As said, the cosecant is always larger than 1 or smaller than -1. Let's, for example, try the secant of 95 degrees. So we do 1 divided by cosine of 95 degrees. And we come indeed up -11, which is definitely less than -1. Let's try the cotangent, for example, of 30 degrees. So we do 1 divided by, 1 divided by tangent of what did you say, 30 degrees? I forgot. Doesn't matter. At least that's kind of number I wanted. 1 over tangent of 30 degrees. Cotangent 30 degrees, 1.73. Or we do 1 divided by, let's say, the cotangent of 70 degrees. So 1 divided by tangent of 70 degrees. And we come up with a number that is less than 1. Negatives, we can have those too. For example, cotangent of 280 degrees. So 1 divided by tangent of 280 degrees, -0.17, or cotangent of 300 degrees. No, that's not enough. Cotangent of 340 degrees. So 1 divided by tangent of 340 degrees. negative 2.74. As I said, they can take on the whole real numbers. One thing to point out again, make sure that your mode is in degrees and not in radians. Okay, let's go back to the lecture in Word. Okay, ratio identities. I had pointed that out already, a little premature, that the tangent is the same as sine theta divided by cosine theta. How can that be? Well, the way we had sine defined was as y divided by r. And the y we had cosine defined as x divided by r. So as we do the algebra on this one here, we would of course multiply with the reciprocal, so we have y over r times x over r. I'm sorry, y over r, might as well write it down, I guess. Y over r times r over x, and of course the r cancels, and we have y over x, which indeed is the tangent. So that's how that ratio identity comes about. Other ratio identities would be that the cotangent is cosine over sine. I'm going to abbreviate this a little bit here. So cosine over sine is the cotangent. Let's look at that on the graphing calculator. That indeed, that is correct. So let's see. Clear all of this. Let's say 35 degrees. Sine of 35 degrees divided by cosine of 35 degrees equals 0.700. Tangent of 35 degrees, the exact same thing, 0.700, just like we expected. And going back to Word. The above, memorize tangent theta equals sine over cosine theta, and that's easy to also memorize cosine theta. Cotangent theta equals cosine theta over sine theta. The Pythagorean identity says that cosine squared plus sine squared equals 1. How does that work? Well, let's look at it in the proof, and you pretty much actually find that in the book. What is cosine squared? Well, cosine is defined as x over r. So I'm going to type in here, oops, x over r, and of course that needs to be squared. Sine is defined as y over r, and that needs to be squared. Y over r. And what do we get on the other side? Well, we're getting x squared plus y squared divided by r squared. And now, because x and y, the coordinates in the right triangle, x squared plus y squared is actually r squared. So that's actually an r right here. And then, of course, equals 1. And really, that was the proof for the Pythagorean identity. This one here, definitely memorize. There are a couple others which are 1 plus tangent, and I think I'm going to steal this here for a moment. Actually, I think I'm going to put these down here. So 1 plus tangent squared equals secant squared. And it can be actually proven in just the same manner when you plug in y over x for the tangent, and then you square it, and then you plug in r over x for the secant and square it, and then you combine them, and you'll see that you come up with this identity. And the third Pythagorean identity is 1 plus cotangent has what is called a squared equals cosecant squared. Let's do this on the graphing calculator. Reciprocal function. A couple of examples. Simply the reciprocals of these here. So for sine theta, that would be cosecant. So let's say equals sine squared. The goal is going to be r over y. Sine of 48 degrees. Well, yeah, you do memorize these as well. Square this as plus cosine squared. Notice that I put them actually cosine in parentheses. I believe I don't have to do that, but I want to be on the safe side. What should we come up with? Well, they're Pythagorean, or they're part of a Pythagorean triangle, the sine and the cosine, so, and divided by the hypotenuse, and so we come up with 1. The other identity, and I mean, let's use again with some other kind of angle here. I only showed it for 48 degrees. Let's make it 21 degrees. Of course, I have to change both. 21 degrees, and again we come up with 1. That's not the proof, you just saw the proof. These are just a couple of values with which we check it. One of the other identities was, for example, 1 plus tangent squared, so let's say tangent of 68 degrees maybe, and then we square that, 7.12, and that should be the same as secant squared. So what I'm going to do is parentheses 1 divided by cosine of 68 degrees, and I square that, and we come up with the same result. So again, there's a checking value for this identity. I noticed that sometimes I'm a little bit too quick. Let me go back to the graphing calculator. Sometimes I'm a little bit too quick on moving out of here, and then it hasn't updated the screen. So I'm going to leave it on a little bit, a few more seconds here, and then now I go back to Word. I hope I don't do that too often. eLife isn't as fast as the way I can type. There are equivalent forms to the Pythagorean identities, where you simply solve for cosine theta. So this one here would look as cosine theta equals, get the sine squared on the other side, so it's going to be 1 minus sine squared theta. Take the square root, and because you take the square root, you also come up with the two solutions of plus and minus. So that's the equivalent form to this Pythagorean theorem. Of course, there's also equivalent form of saying that sine theta equals plus minus square root of 1 minus cosine squared theta, and the same would be for the other two identities. You don't have to memorize these equivalent forms. Why not? Because you can simply do the algebra on these here if needed, and develop them from the Pythagorean, in one step from the Pythagorean, just like I did. Here's an example. with cosine theta equals 1/2 as a given. Determine with theta in quadrant 4, find the remaining trig ratios. So we have that cosine theta equals 1/2. How are we going to do that? Well, that means that for that our x equals 1 and our r equals 2. I know that these boxes here, actually there are 2 boxes, and then there must be here 4 boxes here, which makes sense. 2/4 is the same as 1/2. So we have x equals, it does that to me all the time, and it capitalizes beginning. So x equals 2, r equals 4, which then gives me cosine theta equals 1/2. What are the others? Well, we would have to determine what y is first in order to figure out the sine and so on. So I use the Pythagorean that I say, okay, 4 squared minus 2 squared, take the square root of 12, and we come up, simply the square root of 12. Respectively, if I do 2 squared minus 1 squared, take the square root, it's simply going to be the square root of 3. Well, here it's going to stay the square root of 12, I'm sorry, using these numbers. So square root of 12. Okay, then of course, as I have already listed it, cosine theta equals, well, 2/4, which is 1/2. Then sine theta equals y/r, so square root of 12/4, and if we take that apart a little bit, it's going to be the square root of 3/2. You can easily check that. So square root of 3/2. Notice that the square root is only above the 3. Yeah, you can just do that easily on the side. And here I have to amend something that is actually not correct. Notice that theta is in quadrant 4 as the drawing shows, which means the y is negative. So as we took earlier the square root of 12, we have to keep in mind that we can come up with 2 values, plus or minus, but it said theta is in quadrant 4, so that should be a negative. The tangent, by the way, the identity that we had used here was the Pythagorean identity. Tangent theta, well, we could, for example, use sine theta and cosine theta. So we have 3/2 divided by 1/2, and we come up with square root of 3. And then we use the reciprocal identities, where we're saying, okay, the secant theta is the inverse of cosine theta, so it's 2/1, which of course is 2. The cosecant theta is 2 over the square root of 3. And the cotangent theta is 1 over the square root of 3. So that way we used the different identities, or here we got the Pythagorean identity. And then we use the definitions here. And I have to amend myself. Actually, what we're supposed to do here is use the Pythagorean identity, as it lists that we would have 1/2 squared plus, you know what, I'm gonna leave it here, plus sine squared theta equals 1. I'm going to borrow the square here. And then we're supposed to do the algebra where we come up with sine theta equals the square root of parentheses 1 minus 1/4. And then, of course, we have square root of 3/4, which is square root of 3 over 2. Just the same. That's actually what we're supposed to do to figure out the sine. And then the tangent, here we used the ratio identity for sine and cosine, and then here we simply use the reciprocal identities for the other three. With that, I'm concluding this lecture on basic identities.